Hello everyone, thanks for stopping by. Today we're going to be talking about Math 120, section 10.2, and this is going to be all about loans that involve simple interest. Now, we have seen the simple interest formula before, and I've already written it here for us. It's interest equals principal times rate times time. That's the simple interest formula. Remember, I equals PRT. And it's important to note that the rate is a decimal. It's a decimal number. It's usually given to us as a percentage, but we need to convert it into a decimal. Now, there's some banker's rules we're going to have to keep in mind. Now, according to the bankers, a month always has 30 days when working with these simple interest. If it doesn't specify the month you're looking at, they have 30 days. A year has 12 months, and a year has 360 days. These are just to make the numbers easier to calculate. They round them down to the nearest multiple of 10 for the days in both of the month and the year category. So keep these values in mind. Keep those values in mind. We're going to be using those in some of these examples. Now, let's take a look at an example. Let's see how this works. Sherry needs $6,200 to replace the roof of her home. All right. From her credit union, she obtains a 30-month loan with a simple interest rate of 5.75%. Calculate the simple interest she has charged on the loan and determine the amount, principal plus interest, Sherry will pay the credit union at the end of the 30 months to pay off her loan. Now, let's take a look at our values. We have the principal. The principal was $6,200, right? The question told me that. The time was equal to 30 months. So I'm going to write 30 months. And the interest was equal to 5.75%, which, remember, it needs to be a decimal. So I'll take 5.75% and divide it by 100 to get 0.0575. 0.0575 is the rate as a decimal. Now, I have all the information I need to calculate the simple interest. I need to be careful, though. Time is in months. So when I set this up, I need to divide the months into years. So if I'm setting this up, the interest will be equal to the principal, 6,200, times the rate, 0.0575, times the time. It's 30 months and 12 months make a year. So for the time, I need to do a bit of division, right? I need to do a bit of division. If I'm looking at this, this means the interest is 6,200 times 0.0575. 30 divided by 12 gives me 2.5. So now that I've figured out what was going on for time, a 30-month loan is a 2.5-year loan, right? So let's see. I'm going to take 6,200 times 0.0575 times 2.5. Gives me 891.25. 891.25. And that's dollars, right? That's dollars because it's interest, right? And that was part A. I calculated the simple interest she was charged. For part B, determine the total amount she'll pay back, right? Well, if she's paying this much in interest, $891.25, and she also has to pay back the $6,200 she borrowed, well, then that's going to give me $891.25 plus $6,200 is going to give me $7,091.25. $7,091.25 will be the total amount she has to pay back the bank, right? That's her interest plus the amount she borrowed tells you how much she has to pay back the credit union, right? And we've already seen some examples like this, right? We've already been working with simple interest in a previous chapter. We saw an example with simple interest. But now we're going to be doing them a little more specifically. Now let's look at this. Philip agrees to lend $850 to help his friend Joe, to help Joe travel to Cincinnati for a wedding. So Philip's given his friend Joe money to travel to Cincinnati for a wedding. All right. 9 months later, Joe pays Philip $901. What is the annual rate of interest that Joe paid to Philip? That is what I am looking for. Now, he paid him in total $901, but borrowed $850. The first thing I notice is I can actually calculate the interest amount, the amount of physical dollars that Joe paid to Philip in interest, right? If I do 901 minus 850, that tells me that he paid $51 in interest, right? That's the first thing I'm going to get. Now, time was also 9 months, right? 9 months. MO can be used for months if you're familiar with some abbreviations. Now, what is that in years? Well, 9 months out of 12 months for a year is 0.75 years, right? We can convert months to years, 9 out of 12, right? Remember, we use these numbers for converting. So I've got some things. I also have the principal, don't I? The principal was $850. He originally borrowed $850. And the only thing I don't have is the interest rate. Right? If I use my formula, I equals PRT, I will have 51 equals P is 850. We have R, which I don't know. And we have time, which is 0.75. Well, this is multiplication, so I'm going to get 51 is equal to, let's see, multiplication, I can multiply 850 times 0.75 to give me 637.5, and there's still an R. To get R alone, I can divide both sides by 637.5, divide both sides by 637.5, and I'll be left with R equals, let's see, 51 divided by 637.5 gives me 0.08. So 0.08. But be careful, we're not done yet. This needs to be converted to a percentage. This is a decimal. Remember, you get decimals from the formula. Percentages are for understanding. Decimals come from the calculations. So to turn this into a percent, I would multiply by 100, right? Which will tell me it was an 8% rate of interest. An 8% rate of interest. Joe paid 8% interest on his loan from Philip. Let's take another example. To obtain money for new eyeglasses, Gilbert decides to pawn his trumpet. All right, so Gilbert is pawning his trumpet. Gilbert receives $240 for the trumpet. So that's the principal, right? That's how much money he's getting. $240. And after 30 days, gets his trumpet back by paying the pawnbroker $288. So the time is 30 days. 30 days is the time. Now, right away I know I need to turn that into a year. So if there's 30 days, and remember, for our purposes, 360 is how many days are in a year for these calculations. 30 out of 360. Well, if I divide 30 by 360, what do I get? 30 divided by 360 gives me 0.0833333, right? 1, 2, 3, 4, 5 threes, years, right? Makes sense. It's a small fraction of a year, right? Now, let's see. I'm looking for the rate of interest again, so the R is unknown. I'll put a question mark. Now, interest. I can calculate the interest once again, right? I know the payback and the original amount given. So it was paid back for $280, and originally it was for $240. That gives me a difference of $48, right? The interest was 48 bucks. So once again, I can set up my formula. Interest equals principal times rate times time, which is a bit messy. Multiplying here, I can get 48 equals 240 times 0.08333333 is going to give me exactly 20. Be careful with the decimals. Your calculator might tell you it's 19.9999999. It's actually 20. If you multiply, if we use this number instead, 240 times 30, 240 times 30 gives me 7,200 divided by 360. If I didn't use decimals, I'd have gotten exactly 20. Be careful with the calculator sometimes. You want to make sure, always double check if something works out to a whole number. If you get 0.99999 or something close to a whole number, double check the math. Make sure it works out. Be careful with your calculator. Well, we multiplied. Now we can divide to get R alone. Gives me R equals 48 divided by 20. Let's see, 48 divided by 20 gives me 2.4. But remember, that's a decimal. I need to convert it to a percent. Converting to a percent times 100 gives me 240%. That's a pretty steep interest rate, isn't it? That's a pretty steep interest rate. Does it make sense, though? Does it make sense? It should, because think about the scenario. In only 30 days, the price went from 240 to 288. That's a significant change in 30 days for the interest. That's how pawn shops typically make their money. If you sell something to a pawn shop you intend to buy back in the future, you are going to be paying a massive interest rate. In this case, 240% interest. That's a pretty healthy interest rate, isn't it? So just be wary of that, especially in the real world. Sometimes interest rates might be absurd. Things like credit cards, pawn shops, payday loans. Those sort of things tend to have outrageously high interest rates. So always, be careful with the math. Make sure you're understanding the interest rates, right? Now, let's look on the next page. Let's look at a definition, a discount note. A discount note is a simple interest loan for which the interest is paid up front on receipt of the loan. When you receive the loan, you're getting the interest paid immediately. It's a discount note. A lot of banks do this. Some banks do this when you're borrowing smaller amounts of money. Sometimes it's called a bank discount note. It's going to be a little bit different when we're working with a discount note. We have one example here for it. So let's take a look at how it's different. You pay the interest up front rather than at the end of the months. So let's see. Siegfried took out $500 loan using a 10% discount note for a period of 3 months. So the time was 3 months, which right away I know I'm going to have to put out of 12, right? 3 out of 12 will give me the number of years, which is 0.25 years. 0.25 years. Well, I know the principal is $500, right? And let's see. I don't know the 10% part. Let's see how we're going to use that. Determine each of the following. The interest she must pay to the bank on the date she receives the loan. So Siegfried, she received the loan. How much does she have to pay back? Well, the rate here is 10%. So for part A, let's look at what we got. We have interest. How much does Siegfried have to pay on the day she receives the loan? Well, it'll be interest will be principal times the rate. Be careful. I wrote 10% here. You actually want to use 0.10. Remember, it always needs to be a decimal. Times the time, which is 0.25. So when I multiply all that together, let's see. 500 times 0.1 times 0.25 gives me $12.50. I added a zero because it's money, right? 12.5 is actually 12.50. So the interest she pays when she receives the loan is $12.50. So that is part A. She pays $12.50 at the moment of receiving the loan. So how much does she actually get? When she shows up to the bank gives her $500, but she gives the bank $12.50. So part B is asking us the net amount of money she receives from the bank. Well, if she's paying the bank $12.50 and receiving $500, I can subtract them to see that she's actually going to receive $487.50. And I'm going to put a little dollar sign next to it. She's actually receiving, on the day she goes to the bank, $487.50. Pardon the sunshine coming through. $487.50. That's how much she actually receives from the bank. So this is how much she is actually borrowing when she gets her money, right? So we're going to calculate the actual interest rate. The 10% is not her actual interest rate. We're going to recalculate using the same formula, but now we're going to plug in different values. The interest she paid was still $12.50, but the principal she actually received was $487.50. I want to know the true rate, and the time is still 0.25. With discount notes, the 10% given to you as the discount note price is not the real interest rate, because you're not actually receiving the $500. You're actually receiving slightly less, right? Now, once again, we can clean up the right-hand side by multiplying. We have 0.25 times 487.50 gives me 121.875 R, and that should be equal to 1250. We got to divide both sides by 121.875, right? Divide by 121.875. Divide by 121.875 will give me R equals, let's see, 12.50 divided by 121.875. Now, remember, that's the decimal. I want a percentage, don't I? This is a decimal. I can multiply it by 100 to get the percent. So maybe 10.3 or 10.26, maybe. Let's go to two decimal places. 10.26% is her actual interest rate. Notice this was a little deceptive, wasn't it? The 10% discount note is slightly deceiving. The real interest rate is actually a smidge higher. And that's part of the marketing, right? Seeing the 10% is slightly misleading. That's part of the marketing the bank is doing, right? So keep that in mind when working with these problems. When you see the word discount note, remember, the interest rate is going to be slightly deceiving, as we just saw in this example with Siegfried. Now, let's look at another example that definitely happens in real life. Rodney owns a snowplow business. All right. He needs to purchase a new plow for the front of his truck, but doesn't have the $1,600 purchase price. That makes sense, right? That's a lot of money to have on hand. The dealership offers him two payment options. So I have two payment options. With the first option, he can pay a down payment of $800 and then pay $850 in 6 months. All right, so that's option one. For the second option, Rodney can pay a down payment of $400 and then pay $1,380 over 9 months. Which option has a higher annual interest rate? So I have to calculate the interest rate for both of these. Now, let's take a look here. In the first example, Notice, so let's do option 1 first. Option 1. And then we'll do option 2 second. So let's do option 1 first. Save yourself some room for option 2. Pardon me, I'm going to scoot that sunlight out of there. It's been giving me issues with recording recently. Let's see. So with option 1, how much money is he actually borrowing? Let's see. He borrows... Let's see. He needs $1,600. And he's paying a down payment of $800, which means he's actually borrowing $800, right? He needs the extra $800. So his principal is $800 in option 1. His time is 6 months, which 6 out of 12 is 0.5 years, right? It's half a year. And his interest, how much interest does he pay? If he's borrowing $800 but pays $850 over the course of the 6 months, he's paying $50 in interest, right? $50 in interest. So in this example, the interest is 50 equals the principal is 800, the rate is unknown, and the time is 0.5. Well, rearranging on the right gives me 400R. Dividing by 400 on both sides, dividing by 400, gives me a rate equals, let's see, 50 divided by 400. 50 divided by 400. That's the decimal, though, but I want the interest rate, so I need to make it a percent. Times by 100 to make it 12.5%. Option 1 has a 12.5% interest rate. Let's look at option 2 now. Let's look at option 2. We need to do the same thing. We need to figure out how much he borrows. Well, how much does he borrow? Let's see. He needs $1,600, and now he's making a down payment of $400, which means he's actually borrowing $1,200, right? So his principal is $1,200. That's how much he actually needs to borrow for the second option, right? Now, the time for the second option is different. This is a 9-month loan, 9 months, which 9 out of 12 is 0.75 years, right? It's 3/4 of a year. 9 months is 3/4 of a year, right? Now, the interest he pays this time, let's see, would be $1,380 minus his principal was $1,200. He's paying $180 in interest for option 2, right? He's borrowing $1,200, but he's paying $180. Now let's take a gander at what's going on here. Let's plug in into our formula. The interest should equal the principal times the rate, which is unknown, right? We're looking for the rate, times the time. 0.75 years, right? Multiplying here will give us 900 R. You don't need the parentheses. I don't know why I wrote them. Should be 180. Divide both sides by 900. R will be equal to, let's see what R is equal to. 180 divided by 900 gives me 0.2. 0.2. So let's see. 0.2 times 100, right, will give me 20%. Remember, when you divide, you're getting the decimal. You got to convert it to a percent at the end. So we have 12.5% and 20%. So which one has the higher annual rate of interest? Option 2 has a higher interest rate. That is my answer. Option 2 has the higher interest rate. So, if possible, Rodney should choose option 1. Why might he not be able to choose option 1? Well, it depends on how much money he has up front. With option 1, he has to pay $800 up front. What if he doesn't have $800 up front? What if he can only afford the $400 down payment? He would have to go with option 2 then, correct? But it's more financially responsible if he can to take option 1. And these are real things to consider. The down payment was different, and so was the interest rate. That is a common thing in real life. Typically, the smaller the down payment, the higher the interest rate. That is how things make money. They lower the down payments to bring people in, and then they have higher interest rates to make the money back in the future. So between these two options, Rodney needs to make a decision. Does he want to pay more money up front, but less money overall because it's a lower interest rate? Or does he want to pay less money up front, but more money overall because it has a higher interest rate? And those are real things to consider, right? Now, we have some more notes in 10.2. However, given the length of this week's videos, we are going to pick up this part of 10.2 next week when we also upload 10.3. We will continue 10.2 continued with 10.3 next week. This will be continued with 10.3 next week. We'll continue these topics in 10.3. That is all we will have for this section today. We have one more definition and two more examples to look at that we will look at for next week. That'll be mixed in with the 10.3 notes. So we'll start some 10.2 and then we'll move right into 10.3. So keep that in mind for next week. That is all for this week's notes. Thank you for stopping in to see 10.2, and I will see you next time.